Here are the solutions for Lesson 7-3, Day 1. Solve these equations. Show your work. And a tip, stretch out the expressions. What I mean is sort of spread them out to leave room in front of each term, because we know what the technique is going to be, right? We have to multiply each term by the LCD. So it's nice to have a little bit of room to write that in there without having to smush it in too tightly. So number 5, here's an equation which is made from fractions. So we want to figure out what the LCD is. One denominator is 3, another denominator is 4. The least number, that's a multiple of 3 and 4, is 12. We want to multiply all terms by 12. So that's why leaving space between them is helpful, because I have room to go 12 times the first term. And I've left room to go 12 times the second term, and I've even left room to go 12 times that last number. If I hadn't have left some space in there, I'm going to have to really write small to try to squeeze the 12 in, and then it just gets kind of sloppy. Now, the reason that you multiply everything by 12 is that so when you do canceling, you create an equation that doesn't have any denominators anymore. 12 over 3 reduces to a 4, and so this is 4 times w, which is 4w. 12 over 4 reduces to a 3, and in front of that 3 there's a plus sign. This makes plus 3w. Now on the right side of the equals, 12 over 4 reduces to 3, and 3 times 7 is 21. Look what we created. We created an equation that doesn't have any fractions. So this is way simpler looking than that original equation. 4w plus 3w makes 7w, and 7 times 3 is 21, therefore w is equal to 3. We're going to repeat this technique for the other problems. Because they have fractions, figure out the LCD. One denominator is 5. The next denominator is 2. The next denominator is 20. The LCD of those three numbers is the number 20. Multiply them each by 20. That's why it's helpful to leave enough space in there. Now the canceling. 20 over 5 reduces to a 4, and 4 times 3a is 12a. 20 over 2 reduces to a 10. In front of the 10, there's a minus sign, so this is negative 10a. And 20 over 20 reduces to a 1. This is 1 times 1, which makes 1. We created an equation that doesn't have any fractions. 12a take away 10a combines to 2a, and therefore a is equal to 1/2. Number 9, the LCD of the denominators 5 and 7 is 35. Multiply each term by 35. Put parentheses around that binomial to remind you later that you need to do the distributive property. Now the canceling. 35 over 5 reduces to 7. 7 times x is 7x. 35 over 7 reduces to a 5. In front of that 5 is the negative sign, so think of it as negative 5 and distribute it to both terms. Negative 5 times x is negative 5x. Negative 5 times 4 is negative 20. On the right side of the equals, 35 times 0 is still 0. Combining like terms, we get 2x. Adding the 20 to the other side, we get equals to 20. 2 times 10 is 20, therefore x is equal to 10. The next one has some denominators. The LCD is going to be 15. Multiply by 15 to that binomial. Multiply by 15 to that binomial. And multiply that last thing by 15. Notice how helpful it is for me to have thought ahead of time that I'm going to need some space to show my work. Now the canceling. 15 over 3 reduces to a 5, and that 5 gets distributed to the binomial. 5 times 4y is 20y. 5 times 1 is positive 5. Now the next one. 15 over 5 reduces to a 3. In front of the 3 is the negative, so think of it as negative 3 when you distribute. Negative 3 times 2y is negative 6y. Negative 3 times 1 is negative 3. Now what happens on the right side of the equals? How does the reducing work? How does the multiplying work? 15 over 5 reduces to 3. 3 times 3 is 9. Combining like terms, 14y. And combining the constants, 5 minus 3, that makes positive 2. Subtract 2 from both sides. Divide by 14 on both sides. And the answer is 7 over 14, which is 1/2. Question 13. This equation does have fractions. There are denominators. So figure out the LCD. If one denominator is 5 and the other one's 10, the least number that's a common multiple is the number 10. We're going to multiply all terms by 10. 10 times the first term. 10 times the second term. 10 times that term. And 10 times that last term. Man, it was sure helpful that I thought ahead of time about needing space. 10 times 3u is 30u. 10 over 5 reduces to a 2. In front of the 2 is a negative. That's negative 2 times u, which is negative 2u. 10 times 1 is 10. Now in the very last position, 10 over 10 reduces to 1. 1 times 8u is positive 8u. Now we have an equation with no fractions. On the left side of the equals, there are two terms. They both have u. They can be combined together to 28u. Now our equation has the letter u on both sides. I want to collect the u terms on the left side only. To do that, I'll subtract 8u from both sides. That causes the u term to be removed from the right side of the equals. This becomes 20u is equal to 10. 20 times 1/2 is equal to 10. Therefore, u is a half. Number 19. This is an equation to be solved, and there are fractions in the equation. So the technique is to figure out the LCD. One denominator is 2, the other denominator is 3, the LCD is 6. Multiply by 6, multiply by 6, and multiply by 6. Now the canceling. 6 over 2 reduces to a 3. 3 times 1 is like this part here being a 3, and that can be distributed to the binomial. That makes 3x plus 12. Now in the center of the problem, 6 over 3 reduces to a 2. 2 times 2 is like this, being a 4. And in front of that, there's a negative, so think of it as being negative 4, and distribute it to the binomial. Negative 4 times x is negative 4x, and negative 4 times negative 1 is positive 4. On the right side of the equals, now it's 18. Here's an equation with no fractions. The left side of the equals has some combining to do. 3x minus 4x is negative 1x. 12 plus 4 makes 16. Subtract 16 from both sides, getting a 2. If the opposite of x is positive 2, then x must be negative 2. Now there's 2 word problems to do on page 300. Here is number 1. 1/4 of a number is 2 more than 1/5 of the number. Find the number. This problem discusses some unknown number. Let's choose the letter x to represent that. By choosing the letter x to represent the number, then when we read the sentence, every time we come across the words the number, we can put the letter x for that. So let's read the problem again and translate it into symbols. 1/4 of a number can be written as 1/4 x. Now the word is, that's an equals. Now, 2 more than something is when you add 2 to something. Now, what are we adding the 2 to? Let's read further. 1/5 of the number. That's 1/5 x. Here is our equation. Now, have I written it stretched out enough that I've left room when I multiply everything by the LCD? I'm not happy with how close my 2 is to my plus sign. I want a little more space in there. So I'm going to move the 2 over, leave myself a gap that I can fill in with my work step. The LCD, when you have a 4 and a 5, is the number 20. We'll multiply the first term by 20, the next thing by 20, and even the 2 by 20. 20 over 4 reduces to a 5. 5 times 1x is 5x. 20 over 5 reduces to a 4. 4 times 1x is 4x. Plus 20 times 2 is 40. Now we can solve this equation. Collect the x term on the left side by subtracting the 4x. This makes x equals 40. What was the letter x representing? It was representing the number. The question asks us to find the number. And so our answer is 40. Now number 3. 2 numbers are in the ratio 5 to 2. 1/2 of their sum is 10.5. Find the numbers. We don't know what the numbers are, so we definitely need to use a variable. Now we are told that the numbers are in the ratio 5 to 2. So I can represent one of the numbers with 5x, and I can represent the second number with 2x. Now let's read on. 1/2 of their sum. That's 1/2, and then in parentheses, we'll put their sum. Well, what does the word sum imply? That's when you add things together. What are the things we're adding? The 2 numbers. Remember, we were representing one of the numbers with 5x, and the other one we were representing with 2x. Now it says is. That's an equals. And now it says 10.5. 10.5 is a mixed number. Now I can write 10.5, or I could write the decimal 10.5, or I could write it as a fraction. I'm going to choose to write it as a fraction. 2 times 10 is 20. 20 plus 1 is 21 halves. Okay, so this 10.5 is the same thing as 21 halves. Now we have an equation that has the fractions in it. So we can use our technique from today. The only denominator is a 2. Let's multiply this by 2 and over here by 2. 2's cross out. And we're left with just the 5x plus 2x. Now on the right side of the equals, the 2's cross out. What are you left with? 21. 5x plus 2x is 7x. 7 times 3 is 21. Therefore, x equals 3. Now, is the answer to the question 3? What were we asked to do? We were asked to find the numbers, plural. We're looking for 2 numbers. Now, we even described them. One of the numbers is given by 5x. And we now know the answer for x. We can figure out what 5 times 3 is. 15 is one of the 2 numbers. We represented our other unknown number with 2x. So what is 2 times 3? Our other number is 6. The sum of 15 and 6 is 21. 1/2 of that sum is 10.5. And 15 compares to 6 in the same way that 5 compares to 2. This concludes the video.